topic of this video is determining the inverse of a function. Given a one-to-one function, its inverse, also a function, is obtained by swapping inputs and outputs. This symbol, shown here highlighted in blue, denotes the inverse of f. We pronounce this f inverse of x. We do not say -1 because it is not an exponent. It is a mathematical symbol that is indicative of the word inverse. Let's look at some examples. All right, on the left we have a function f. This is a mapping, also known as an arrow diagram, where the input is the order that a person was the United States president, and the output is the last name of that person. So, the input first leads to the output, Washington, and so on and so on. This function might be useful as an app in a US government class. If someone says, who was the 45th president of the United States, you could enter it into the app, and it would tell you the last name. Now, what if, instead, someone said, okay, Donald Trump became president January 2017, but what order president was he? Does function f help us answer that question? Well, maybe, if we had that as an app, we could just guess numbers all day long until eventually the name Trump comes out. However, wouldn't it be far more efficient if we had an app that we could reverse the input and output? For example, an app that allows us to enter the name of the person as the input and then just tells us what order that person was president. Such a function is called an inverse. When you swap inputs and outputs, you have a new function, and we name that function with this symbol right here. This is the word inverse. So the function on the left is function f. The function on the right is function f inverse. And by the way, President Trump is the 45th president of the United States. All right, let's now look at a different collection of functions. Here we have the function g, which is a set of ordered pairs, 2, 2, 3, 8, 4, 42, 5, 88. What would the inverse be? The function g inverse is obtained by swapping all the inputs and outputs. So we would have 2, 2, 8, 3, 42, 4, and 88, 5. Notice that the first ordered pair in both functions is identical only because the x and the y coordinates are the same. All of the others have had their coordinates swapped. Finally, we turn our attention to graphs. If someone gives you a graph of a function and asks you for the graph of the inverse, all you have to do is swap all of the x and y coordinates of all of the points on that graph. We will also learn that the graphs of f and f inverse will be symmetric about the line y equals x, which is shown here in this diagram. With this information, we can find the inverse when we are provided with an arrow diagram, also called a mapping, a collection of ordered pairs, or a graph.